Hello friends, welcome to CEC Live Lectures, dear friends, with our ongoing series on cloud computing. Today also we are going to talk on cloud file system. This is the second session on cloud file system. In our previous session, we discussed a lot under the topic, and today we are going to discuss on Hadoop distributed file system and HBase. And for the discussion on the topic, we have with us in our studios Dr. Kashish Ara Shakil. Dr. Kashish Ara Shakil is Assistant Professor in Department of Computer Science and Engineering, Jamia Hamdard. Dr. Kashish Ara Shakil is a prolific professor and she believes in giving her best. She is a young professor who always believed that whatever she has gained should be distributed, should be disseminated to the students. So friends, let's take advantages from her experiences and let's try to understand more about cloud file system. Hello.
Yeah, hello. Hi everyone. Today we'll be continuing our series on cloud file systems. In the last series, we had discussed on data management in cloud. Then we moved on to cloud file systems in particular, where we studied about Google file system and BigTable. So today we'll be just going into a little depth on BigTable. Then we'll be continuing with newer topics on cloud file systems like Hadoop distributed file system and HBase. So as per the last lecture, we had studied about BigTable. We had studied that BigTable is similar to a database, but it is not a relational data model. In fact, it is a kind of map, and the data in BigTable is indexed using row and column names. And each of the data is treated as an uninterpreted string. And like in the last lecture, we had discussed about Google file system. This BigTable is built on top of the Google file system, and it uses MapReduce programming paradigm for processing in a parallel manner. So the data model of BigTable is basically, BigTable is a kind of sparse database. With the term sparse, we mean a lot of empty values in the columns, in the rows will be there, and it is a distributed multi-dimensional sorted map. So the data in BigTable, it is organized into 3 dimensions. One is the row, then second is the column, and the third is timestamp. So like in any relational database also, we have data organized into rows and columns, but here we have one additional thing, which is the timestamp. So timestamp is basically used for versioning control and for knowing that when a user has gained access to the database. So this data model is basically used for keeping in mind a variety of potential uses. For example, for collecting large number of web pages. For example, Google, it maintains this BigTable for storing large amount of web pages, because Google, it comprises of thousands and millions of web pages. So all these web pages, they are kept in something called as BigTable. We had already discussed a lot on BigTable, but right now we'll just focus on the data model of it. And let's have a look at the rows, how the rows are maintained in BigTable. These rows, they are maintained in an alphabetical order. And these rows are basically arbitrary strings and are units of transactional consistency. So it maintains an atomic consistency whenever a transaction is taking place. And these rows, they are grouped into tablets. What a tablet is, that we have already discussed in the previous lecture. And in case of rows, if the rows are short in ranges, the read will be more efficient. This is basically based on the principle of locality of reference, that the rows which are similar are kept together so we can have a faster read operation on them. And apart from read, the communication between the different elements in the rows is also faster if the similar rows are kept together. Apart from this, we talked about columns. So columns, they are basically grouped into column families, and the general syntax of a column key is it consists of the family and then the quantifier. So the data is stored in a column family. Here also the data of similar type is stored in same column family. This is again for the ease of access and retrieval. So an example of a column family can be a language which stores the data in a web page. So if the data of the web pages which are written in a particular language, say English, are kept together, and the data in some other language, say Spanish, they are kept together, just for the ease of access. Apart from this, like we already said, that they have a timestamp also as one of the key elements. This is for versioning, like I already told you, and these timestamp values, they are changeable. You as a user, as a client, you can set the timestamp values depending upon your requirement too. So data is stored so that new data can be read faster. So this timestamp ordering is also used for retrieval of data. So the data which just came in the database will be kept on the top so that the users can have a faster access. And of course, there can be other algorithms on the basis of which the user data can be arranged in a big table. But timestamp, it helps in achieving these kind of arrangements and facilitate algorithms which can be built on the top of these rows column values, keeping in mind the timestamp. And then apart from this, timestamp ordering also facilitates garbage collection, because garbage collection is also one of the features of BigTable, which we have already studied in the last lecture. So timestamp also helps in the garbage collection, because here if, for example, there might be some data in the BigTable which might not have been referred since a long time. So sometimes based on the algorithms of the BigTable itself, during garbage collection, the timestamp also plays an important role. This is one of the examples where we can store a web page in form of a web table in BigTable. So here the data will be organized in form of rows and columns, and the URLs can be kept as row key value, and different aspects of the web pages, they can be treated as the column names. Different aspects of a web page can be, it can be, for example, it can be language, it can be the kind of web page, whether it is an educational web page or any beauty web page, etc. So this is the way in which BigTable can store a web page in itself. Some of the real-life applications of BigTable includes Google Analytics. Google Analytics, it uses BigTable all the time because it helps them to analyze the web traffic on their websites, because Google, it has millions and trillions of users accessing it all the time. So it uses BigTable in this case for performing its analytic functions. For this, it uses two tables. First table will be for storing the raw clicks which a user is performing, which maintains a row for each of the user session. Whenever a user is clicking something, that is stored in a raw click table. Apart from this, there is also a predefined table which is used for maintaining the summaries of the various websites and web pages. This is how BigTable is used in Google Analytics. Apart from this, BigTable is used in another application such as Google Earth. Google Earth, I'm sure all of you must have been aware what Google Earth is. Google Earth, it provides, in case of Google Earth, what Google Earth does is it provides you with access to a high resolution satellite image of the world's, of the entire world surface, both through web-based Google Maps, and you also have offline Google Maps too. So Google Earth does this. It provides you with a resolution of the entire world map. So all the pre-processing and management of data in Google Earth is done via BigTable, and processing of the data in the BigTable is done via some parallel programming techniques such as MapReduce. This is it for BigTable. So we studied about what a BigTable is, what is the kind of data model which BigTable has, and what are the real-life applications of BigTable. Now we'll be moving on to the next technology, which is Hadoop distributed file system. So before beginning with Hadoop distributed file system, let's have a look and feel of what Hadoop is. What is basically Hadoop? Hadoop is nothing but it's an open source storage and processing platform. So via Hadoop, you can store your data and you can process your data through programming paradigms such as MapReduce. Apart from this, before the advent of Hadoop, storage and processing of big data was a big challenge because the traditional systems, like the traditional relational data models we had and the traditional servers, any kind of traditional system, it was not able to handle the kind of data present in case of big data. It was not able to handle such kind of data. With this need, we had the development, the invention of Hadoop. So Hadoop, it provides massively scalable and automatically parallelizable platform. So this Hadoop is also based on top of Google file system and BigTable. But the difference between the need and the difference between Hadoop and this Google file system is that Google file system, it is not a public platform. It is not an open source platform. But Hadoop distributed file system, it's an open platform, and it comprises of the Hadoop ecosystem. It basically comprises of Hadoop distributed file system for storage, then it comprises of Hadoop MapReduce for processing, and HBase is also for storage, which is an open source platform. So why the name Hadoop? You must have all wondered that what does the term Hadoop means. Hadoop was basically the name of the toy of the inventor of Hadoop, that was Doug Kuttig. So he just named the language, the platform he had developed with on the name of the toy of his little son. So that is how the name Hadoop came. So what does Hadoop offers? It offers redundant, fault-tolerant data storage because Hadoop, it offers data replication. Your data is not stored at one place. Your data is rather distributed on different machines. So it offers a fault-tolerant storage solution. Apart from this, it offers a parallel computation framework in form of MapReduce. So with the help of parallel computation, what you can achieve is you can achieve faster computations and optimized utilization of resources. Apart from this, the jobs, they are all coordinated in Hadoop because Hadoop, in case of Hadoop, the data, the jobs, they are distributed across different we can say mapping tasks and reducing tasks. So all these jobs, they are coordinated together by the Hadoop platform. You no longer have to manually distribute your applications, your data. What you need to do is you just need to feed it into the Hadoop paradigm, and rest everything is taken care of by the platform itself. So you no longer have to worry about where your data is located because that is also going to be handled by the Hadoop distributed file system itself. Then you don't have to worry about the failure and the loss of data because that is also taken care of by the Hadoop paradigm. And you also do not need to worry how the computations are going to be divided, on what basis. So apart from that, you don't have to worry about scalability. So you can use Hadoop for massive computations, for processing of massive amount of data without worrying about how are you going to store it, how are you going to process it, how are you going to distribute the processing. Everything is taken care of by the framework itself. So why do we use Hadoop? Why not use the traditional system? What is the need for just one more platform? The need is, first, it offers a cheaper solution because you can work on your existing hardware. You can use it as a a commodity hardware. So what you need to do is you just need to connect multiple commodity computers, any machine you have at your home, at your workplace. You just need to set up a Hadoop cluster, and then you are good to go. You can just achieve parallel and massive processing in a cheaper manner. And since it does the processing in a parallel manner, it is fast and it is better. How it is better? It is better than the traditional systems because now it can handle massive amount of data and can perform processing in a massively parallel manner. Since Hadoop is the latest buzzword, you can say, not the latest one because it has been quite some time since Hadoop is in the market. So many companies, they are gradually shifting towards Hadoop as a solution for massive storage and for massive processing. So we have companies like Yahoo, we have Facebook, we have Google, then IBM, Amazon, eBay, etc. Loads and loads of companies who are using Hadoop as a platform. So let's have a look at Hadoop ecosystem. We just talked about Hadoop, but Hadoop is not just confined to Hadoop distributed file system. It is not just confined to HDFS. There's a lot more we can do with Hadoop. So at the bottommost layer, you can use Hadoop in form of storage solution, for example, HDFS. Then they have Yarn, which is for management of the Hadoop cluster because you have multiple machines. Apart from that, Hadoop, it provides Hadoop MapReduce, which is for processing of applications in a parallel manner. Apart from that, you have Apache HBase, which is for column storage, and this is for the storage solution. Apart from this, there are many new frameworks which are getting developed on top of Hadoop, we have Mahout, which is for provides machine learning framework on top of Hadoop and provides millions of, not millions, but quite a large number of libraries for carrying out machine learning operations on top of Hadoop. Then we have support for scripting languages like Pig. Then we have Hive, which is very much similar to the traditional DBMS tools like SQL. Apart from that, there are other applications like Oozie for workflows, Zookeeper for coordination, and many more in the Hadoop ecosystem. So let's have a look at Hadoop ecosystem on the basis of functionality. For data storage, we have HDFS and HBase, which we will be discussing today. Then for the processing part, we have MapReduce and Yarn. Yarn is the latest version which was added in Hadoop 2.0. It is for cluster and resource management. Then for data access, we have massive number of applications which are developed on top of Hadoop. For this, you do not have to learn about the internal functioning of Hadoop. So you can use it is very similar to your traditional applications like Hive, which is built very similar to SQL. Then we have Pig, which is a scripting language, which is also quite simple. Then we have Mahout, which offers a wide amount of machine learning libraries. Then we have other data access options like Avro. Then we have Scoop. Scoop and Flume are used for ingestion of data into Hadoop distributed file system. Apart from that, for data management, we have Oozie, which is for workflow monitoring. Then again, we have Chakwa, which is also for monitoring. Then we have Flume, which is for ingestion of data. And then we have Zookeeper, which keeps track of all the management activities in the Hadoop ecosystem. So now let's move from Hadoop. We had a look and feel of what Hadoop is. Now let's go to the bottom layer of Hadoop for management of data, which is the topic for today. That is Hadoop distributed file system. So what are the goals which Hadoop distributed file system aims at achieving? First is it provides support in form of a very large distributed file system So it can expand up to 10,000 nodes. So what do I mean by the term nodes here is the number of computers on which your application can scale up. So it can provide support for very large distributed file system in form of around 10,000 nodes, then which means it can store up to 100 millions of files, and of course up to 10 petabytes of data and much more. Second goal which HDFS aims at achieving is it assumes the presence of commodity hardware. So commodity hardware we've already discussed. So files are replicated to handle hardware failures. So it is not that we have just one copy of a file, single file stored in the HDFS. We have multiple copies of the file which are stored in different parts of HDFS. That is a part of rack awareness, where data, some of the files are stored on the same rack, some of the files are stored on the other rack. That we'll do in detail in the upcoming lectures. Apart from that, it also should be able to detect failures and recover from them, because we said that it is highly available. It offers a highly available solution. In order to do that, it should be able to detect when a failure is occurring, and if at all a failure occurs, then it should be able to recover from this kind of failure. Apart from that, it should be optimized for batch processing, because HDFS, in case of HDFS, mostly batch processes are being submitted. Huge number of applications are submitted in large batches, so it should be optimized for handling batch processing as well. So the data locations in case of batch processing is exposed so that the computation, they can move to where the data resides. What does that mean? Basically, what is there in Hadoop is it moves the computation to data rather than the data to computation. So what it means is that instead of having a huge bottleneck in terms of moving large data, because HDFS does not have to deal with very small data. Generally, it has to deal with a massive amount of data. And if you are moving the data from one machine to another, and for the purpose of processing, this thing can occur as a bottleneck. It will just lead to degradation in the performance of your system. So what happens in MapReduce is your machine, the processing part, is moved to the data, and the data resides at its own location. So it optimizes the performance of the MapReduce system as a whole. And it also, in this case, it saves on the bandwidth, because we are not moving massive amounts of data, we're just moving the processing to data. So this is the general architecture of HDFS. It basically comprises of a name node and several data nodes. So data nodes are built on top of commodity hardware, and then we have the name nodes. So let's have a closer look at the working of HDFS. In case of HDFS, what is there is that the files are divided into blocks. Just like we studied in GFS, we talked about chunks. Here we have data divided into sort of blocks. And each of these blocks, they are stored in the different nodes in HDFS. So, and it is not just one file which is stored. Not a single copy of the file is stored. We can have multiple copies of the file stored to ensure high availability and to ensure freedom from any kind of failure which is occurring. So this is how the data is getting stored. Apart from that, we have two components. We have name node, which is handling on the processing, and then we have data nodes at which the data is getting stored. So what is the function of name node? Name node is, it basically manages the file system namespace. So it maps the file name to a set of blocks, and then these blocks, they are sent to the data nodes, and then they are stored by the Hadoop distributed file system, which is present at each of the data node. Apart from that, it manages the cluster configuration, because we have a cluster of multiple machines. Usually if you're not going for a pseudo distributed mode, if you have a cluster, it is for responsible for cluster configuration management, and then also for ensuring the replication proper working of the replication engine for each of these blocks. A name node, it also stores metadata. Apart from coordinating all these information, it also stores metadata. This metadata is stored in memory. Apart from this, the type of metadata can include a list of files, a list of blocks, a list of data nodes, and file attributes. And of course, it also stores transaction logs, etc. So we'll be discussing more on the architecture of HDFS after a short break.
With this note, thank you, ma'am. Thank you so very much for giving us this session. Friends, we will be back after a short break and would be discussing more. So you are requested to be with us. Thank you. Hello friends, welcome back to this session. Friends, as you know that today we are talking on cloud file system, and specifically we are talking on Hadoop distribution file system. In our previous session we discussed a lot on it, and we will be continuing further from the point where we left in the previous session, that is from the Hadoop distribution file system only. And after completion of this topic we would be covering HBase. For the discussion on the topic, we have with us in our studios Dr. Kashish R. Shakil. Dr. Kashish R. Shakil is a professor of computer science, and through the live platform of CEC, she always tries to give her best to you all, and we believe that you gather maximum knowledge through her. So let's welcome our guest, Dr. Kashish R. Shakil. Hello ma'am, welcome back to the session.
So guys, in the last part of the session, we discussed about the architecture of HDFS, now where we discussed about what a name node is. We'll be continuing from there. Now we'll be seeing what a data node is. So a data node, basically it comprises of three things. One is the block server, which is responsible for storage of data in the local file system, not HDFS. Then it stores metadata about the block. Apart from that, it serves data and metadata to clients. So these are the responsibilities of the block server in a data node. Apart from that, it periodically sends reports of the functioning of other blocks to all the other blocks, and all these reports are sent to the name node because it is managing all the metadata information about all the nodes. Apart from that, it facilitates pipelining of data. So it forwards data to other specified data nodes if a data exchange is required, but this exchange is minimal in Hadoop distributed file system. Then how the blocks are placed in Hadoop distributed file system? We just said that Hadoop distributed file system is not confined to a single file. Each file is broken down into blocks. So how these blocks are going to be placed? So by the default strategy is that one replica of the block will be kept on the local node, then the second replica will be kept on a remote rack, and the third replica will also be kept on the same rack. So why are we keeping second and third replica on the same rack? Is to reduce any kind of overhead in exchange of information. Then any additional replicas, they are not kept on the same rack, they are kept on the different racks. So this is the default block placement strategy, but it is configurable and you can configure it on your own. So whenever a client issues a read command, the data will be read from the nearest replica. So apart from that, we can also measure heartbeats from the data node to the name node. So what heartbeats does is, this feature of heartbeats, it's basically tells the name node that yes, a particular data node is still alive, it is working free of any kind of failure, and if any failure occurs, there will be no heartbeat and the name node will automatically come to know that okay, this node has failed and maybe we can move to the next replica of this for this particular file. Then we have replication engine, which chooses new data nodes for new replicas. If in case one of the data node it fails, it's not just for example, if we have corresponding to a file, we have blocks which are stored in say we have corresponding to a file, we have just a single block, and it is if the replication factor is 2. So what does this mean is that we have just 2 copies of this file. So if one of the node it fails, then we are left with only 1 copy. So what will happen if the second copy also fails? So in that case, we can say our system will fail. So what HDFS, what Hadoop offers is that if one of the nodes fails, it automatically chooses an automatic replica of this file as well, so that your functioning of your entire process, it is not hindered. And apart from that, it should all the HDFS, it also ensures that whatever data is present in this file system, it should be correct. How it does is, it uses checksum to validate data. Then apart from that, there is a proper file access order, because the client, it retrieves data and checksums from the data node, and if a client fails to access this data node, then it goes to the replica. Okay, a file, it might happen that a client might not have an access grant for a particular replica, so it will go to the next replica. Maybe it might have a grant for that. So it takes into consideration that data, whatever data is present in the distributed file system, it should always be correct. What if the name node itself fails? So name node is a single point of failure. For this, we have something called as a secondary name node, which occurred in the Hadoop 2.0 version. It was not present in the earlier versions of Hadoop. So let's have a look at some of the common HDFS commands, so that you can just, all of you can have a small hands-on in your systems. So one of the very common command is Hadoop DFS cat. So what this command does is, using this command you can just see whatever is the content in a particular HDFS, in a particular file which is stored in HDFS. For example, if we have a file called abc.txt, the command we'll use is Hadoop DFS, then hyphen cat. Cat is the command for seeing the content. It is very similar to the commands which we use in Linux, and then the name of the file. So here what we have done is we have given the absolute path of the file wherever the file is present. So now it will display the contents of the text. Another command is copy from local. What does this command do is, in case of HDFS, what you do is whenever you want some data, it will initially be on your local machine, and therefore if in order to use HDFS, what you need to do is you need to import your data from your local machine to HDFS. So the command for that is Hadoop DFS : copy from local, and the path of the file on the local file system and the path of the file on the Hadoop distributed file system. What it will do is it will copy the file from the local file system onto the Hadoop distributed file system. So what if we want to do the reverse? If you want to move the data from from HDFS to your file to your local file system, for that case we have the command copy to local. Then in order to remove a file or a directory in HDFS, what we can do is we can use the command hadoopdfs -rm and the name of the file or the directory in HDFS. By the term name, I mean the absolute path of the file wherever the file is stored on HDFS. Apart from that, we can create a directory in HDFS using mkdir. These are all the commands which we have been learning in Linux since a long time. Just we append the word Hadoop DFS. So do try these commands. It will really help you out in learning Hadoop in more depth. Then for listing the contents, we have Hadoop DFS -ls. These ls commands also I am sure you must have all done in Linux. Apart from that, if you want to upload a file in HDFS, for that we have dfs put command. Then for downloading a file, we have dfs get command. So these are the commands which we can use with HDFS. So this is it with HDFS. I'm sure you must have all learned a lot from this, and in particularly my stress is on you guys trying the commands in particular, so that you can have a look and feel of what is going on in HDFS, how you're going to import the data, how you're going to copy, how you're going to display the contents. It will lead to a better learning experience for all of you. The next topic is Apache HBase. Apache HBase is also one of the file systems which is being used in cloud environment. So what Apache HBase is, it is a distributed column oriented data store, and it is built on top of HDFS. So HBase is an Apache open source project whose goal is to provide storage for Hadoop distributed computing. And in case of HBase, the data is logically organized into tables, rows and columns, very much like your relational database. So let's see, where does HBase lie in the Hadoop ecosystem? It lies in the storage layer. This we have already seen in the previous slide. Why did we had a need for HBase when HDFS was already there? So and we just said that HDFS is built on top, HBase is built on top of HDFS. So both are distributed systems. What a distributed file system is, that we have already covered up in the last lecture. And both of them, they can scale to hundreds and thousands of nodes. But when HDFS is good for batch processing. so that it can scan over big files, but it is not good for record lookup. It is gives poor performance when you are performing any kind of lookup operation, and it is not good for incremental addition of small batches, and it is not at all suggested when we have to perform any kind of update operation. In these kind of scenarios, what we could prefer is we could go for HBase. HBase is designed to efficiently address the above points. What were the points? The points were poor lookup, incremental addition, and for the case of updates. These were the points. So now what HBase has to offer is it will offer you a faster record lookup, and it provides record level insertion, and apart from that it provides support for updates. So that is the reason why we have the development. There was a need for HBase, and HBase came about. Let's have another look at the difference between HDFS and HBase on the terms of the kind of facilities they offer. For example, if we are performing a write operation, if you are going for HDFS, it supports only append. It does not support any kind of insertion in between, no random write, nothing. You can just append. If you want to perform any write operation, you can just append. You can't insert anything or perform any kind of random write. And in case you are going to read, for read HDFS, what HDFS will do is it will perform a full table scan, and if the table is very large, it will partition the table scan, and then it will give you the output. But what HBase does is it provides random read, and the amount of the scan, the range of the scan is also short in comparison to HDFS. So it has a better performance. Then HDFS, with HDFS, if we go for options like Hive, which is built on top of HDFS and provides an interface, or it facilitates querying of the data. So if you are going for Hive on top of HDFS, it will give you a very good performance. But if you will go for HBase, the performance will be a bit slower. It will be like 4 or 5 times slower, not bit, it will be a lot more slower. And HBase, it is sparse column family, and apart from that, the amount they are different on the basis of the maximum data size which they can store. Now let's have a look at how the data is actually getting stored in HBase. What is the data model of the data which is getting stored in HBase? So HBase is based on Google's BigTable model. Google's BigTable model we have already discussed. In case of HBase, the data, it consists of multiple tables, and each of these tables, they will have multiple rows, and these rows are sorted on the basis of the value of the key. Apart from that, each row can contain a row key, and they can have one or more column families. So we will have row, we will have column families, and each of these column families, they will have their own columns. And whenever you are creating a table, the column family is defined at the time of creation. So and of course, like we already said, that column families, it can have multiple columns. So every cell in HBase will comprise of a table, the row, a column family, and its corresponding column. And apart from that, it will also keep track of the timestamps. So it is very similar to the big data model. In big data model also, we had one of the key elements in form of timestamp. Here also we have timestamp as a key element. So this is one of the examples of how data is stored in tabular form in HBase. It comprises of keys, then we have column families, then we have columns. Here 101, 102, 103, these are all the row keys, and if you can have a closer look at this, you will see that these keys, they are present in a sorted order. Apart from that, we have column families. So here name, home, office, these are all the column families, and under these column families we have columns, like we have first name, last name. These are the corresponding columns corresponding to the family name. Then under home you can have phone number, you have email as the corresponding columns. Similarly in case of office. So whenever we are storing some kind of data in your Apache HBase, what you can do is you can add the columns at runtime, but you cannot add the column family at runtime. So column family, it needs to be defined beforehand. You cannot enter a new column family at runtime. So just like in this example, if you have a column family name and you have a column, say first and last name in your table, what you can do is you can insert another column, say middle name in your database, but you cannot insert another family. For example, we can have a family of social account. So you cannot have a new family made up. You can just have a new column made up. So this is how a data is represented internally. So we have a table with the name people. So the name of the table is people. Then it has name, home, and office as the column families. And let's see how the data is stored. 101 is the row. We have the timestamp value also stored here, like we had already discussed that it is very similar to BigTable. So here also the timestamp value will be there. Then home, office, all these are the different, what are these? Home, names, and office, these are the column families. So we have different column families, and corresponding to these column families we have the different column names like first, middle, last. And similarly, for corresponding to home, we have different columns. Home here is the column family, and we have different columns like phone, email, etc. corresponding to this column family. So 102, in this case, it represents the next row or the next tuple, as we talked about in a traditional DBMS. Similarly, you can perform operations like get command, etc. in your HDFS. So if you are getting, if you want to get something from the people's table, if you want to get a particular row, what you can do is you can fire a command get name of the table and the name, the corresponding row key. So if you want to get data corresponding to the row key with the value 101, what command you will use is get people 101, and this is the output which will be displayed. Similarly, if you want to get the information from the entire column family, so what you can do, if you want, in the previous example, what we did is get people 101. What we did is we were able to retrieve the information of the entire row. But if you want to retrieve information corresponding to a particular column family, what you will do is you will use the command get name of the table colon the row key value and the name of the column family. For example, if you want to get information regarding the name column family, what you can do is get people colon 101 and name. So in this case, what you will get is you will get the value corresponding to a particular column family. And if you want to get some more specific information, like if you want to just retrieve the first name, so what you want to retrieve now is you want to retrieve a particular column. In that case, what kind of command you can use is get the name of the table, the row key value, the name of the column family, and then the name of the column itself. So in this case, if you want to get say the first name of a particular row, the command you will use is get people : 101 : name : first, and this is the output which will be displayed in this case. So these are some of the fundamental operations which HBase can support. It can support operations like create table, create families, then it can support operations like put table, row ID, family, column value, put table, then another kind of command, put table, row ID, and then you can get the whole row. Then for get also you can get table, row ID, then you can scan the entire big table, in this case HBase, through scan command, and you can also drop the entire table through a drop command. So these are some of the fundamental operations which HBase supports. So these operations are very similar to the traditional database operations which we have been doing since the time we have been learning about databases. I'm sure all of you must have studied database management system, in that the commands, the fundamental operations you perform are these only. Apart from that, apart from put, get, you usually do not use these kinds of commands, but I believe all of you must have used create and drop command. Let's have a look at the consistency model, how the consistency is maintained throughout in HBase. First is atomicity, how the atomicity is maintained. If you are making any changes in HBase, either the entire row will be updated or nothing will be updated. So what it ensures is it ensures the atomicity in HBase. Then how consistency is maintained, because we have commands like get and we have commands like scan. So how is a consistency maintained? A get is guaranteed to return a complete row that existed in the table, and a scan command will include all the data which is written prior to a particular scan. So this should be done in a consistent manner. Then isolation. So these are all the ACID properties which we have been learning in traditional DBMSs also. Up next is the isolation property. So isolation property is not guaranteed in HBase. Though it was guaranteed in other traditional DBMSs, it is not guaranteed in HBase outside a single row. Then durability. All the write operations that are made in HBase, they are bound to be very durable. So this is the consistency model of HBase: atomicity, consistency, isolation, and durability. Let's have a logical view of HBase. This is very similar to what we have already seen, but this one, it will give you a more clear picture, like how data is logically organized in case of HBase. So we have row keys in form of, it can be anything. So these are primary keys in our DMS. Then we have different types of data separated into different column families, and then we have the corresponding column values corresponding to them. Similarly, we will have another point to be noted is that different rows, they can have different sets of columns. It's not necessary that every row will have a particular column. If I do not have a middle name, that entry will be left blank. So all the rows, they will not have a similar column structure. It can be left blank. So this is the reason why we call HBase as a sparse database. So like we have already seen that HBase is based on key and column families, and these are some of the pointers which should be kept into mind on data model. That HBase, it consists of several tables. Then we have, corresponding to these tables, we have column families, and these columns, they are also dynamic in nature. So this is it from HBase, what we studied today. I'm sure you might have gained, if not all, a little knowledge on HBase and HDFS from this lecture. I hope it would have been a good learning experience for each and every one of you. Thank you.
Thank you, ma'am. Thank you so very much for giving precious input to the lecture and giving us in-depth knowledge too. Friends, if you have any query or feedback regarding this particular lecture, then do write to us at info.cec@nic.in. All the lectures pertaining to the series on cloud computing are there for you on the YouTube. Keep watching all the lectures, and if you feel so that you have something to say, then do contact us through what ID, that is info.cec@nic.in. Today we are taking your leave with the promise that we will be meeting again soon and would be discussing more. Till then, take care. Goodbye. Thank you, ma'am. Thank you once again.